In this video, you will become an expert at solving a triangle using the law of sines method for angle-angle side and angle-side angle cases. So, first thing we want to do is discover where this law of sines came from and what it is. So far, we've learned how to do things when we have right triangles. So let's start by using our right triangle trigonometry we learned last chapter. Take this triangle below, ABC. First thing I'd like to point out is that angle A is always going to be opposite of side A. Angle B is always opposite side B, and angle C is always opposite side C. The reason why we want to know law of sines is because we aren't always given triangles that have right angles, hence this large ABC. So what we can do is we can drop an altitude, which will make a triangle that has a right angle. Let's start with this triangle on the left. Since we are given that angle A is 53 degrees, I'll make that my theta. Once I know that 53 is theta, I know that my altitude, which we'll call h, is going to be the opposite side. I know that the 12 is opposite my right angle, so this would be the hypotenuse. And I know that this part of side B here is going to be adjacent to my theta. If I want to solve for h, the opposite side, and I know the hypotenuse, the function that uses both opposite and hypotenuse is sine. So the sine of 53 degrees will equal the opposite side, h, divided by the hypotenuse of 12. If I put this over 1, I have a proportion that again I can cross multiply and solve. And that tells me to take the 12 times the sine of 53. Let's hold off on solving this until we get our other part of our triangle solved for h. So let's now take a look at the right side of our triangle. Again, our altitude is going to form a right angle, which is going to make side A here the hypotenuse for the right side of the right triangle. And if I make 36 degrees angle C, the angle I'm given, theta, that is going to make h, again, the opposite side. And it's going to make, again, the other part of B the adjacent side. Since here I want to solve for really both h and a, I don't know either of them, but these are the two sides we want to use. So again, I can use the sine function. So the sine of 36 degrees would equal my opposite side, which again is h, divided by the hypotenuse, which is a. If I again put this over 1 and cross multiply, I have h equals a times the sine of 36 degrees. At this point, I have two equations, both equal to h. That means I could set these two equations equal to each other, allowing me to have just one variable and to solve for just this a. So really, I have 12 times the sine of 53 degrees equal to a times the sine of 36 degrees. Now again, if I wanted to solve for side A here, all I'd have to do is divide each side by the sine of 36. And that would give me equal to a. But what I want to show you right now is our law of sines. So let's say that instead of dividing by the sine of 36, I divided each side by a. That's going to cancel there and leave me with this equal to sine of 36. Let's say I also divide each side by 12. What that's going to give me is the sine of 53 degrees divided by a equals the sine of 36 divided by 12. The reason why that's important is because if you look at sine of 53, 53, remember, was this angle A. And look what side is below it. Side A. If I think about the big triangle, that means in one ratio, I have the sine of the angle divided by its opposite side. If I look at the sine of 36, angle C, that's divided by 12. If you again look at the big triangle, angle C, the sine of that is being divided by its opposite side, side C, which is 12. This proportion is our law of sines. So let's write that below. The law of sines takes any two of the three ratios we're about to write and sets them equal to each other to solve for different angle measures and side lengths. And so the first ratio we could use is the sine of angle A divided by side A. Or we could have the sine of angle B divided by side B. Or you could even have the sine of angle C divided by side C. What's basically important to remember is that you always want to take the sine of an angle and divide it by its opposite side. Do that for any two and you'll have a proportion you could cross multiply and solve. So let's go ahead and try this in an example now. So down here in example 1, the first thing I'm going to start by doing is labeling everything I know. I see that I know that side A is a value of 13 units, and its opposite angle, angle A, is 33 degrees. I am also given that angle B is 50 degrees. The reason why I want to label all of those first is because that's going to help me decide what I have as far as an angle that I know and an opposite side that I know. That's also going to tell me maybe an angle or another side I know and what other side I need to solve for first. And so right now we've circled what our two ratios are going to be, and that's going to be enough for us to be able to get our proportion to solve first for side B. So let's start by writing the proportion out. Again, I know angle A, so I want to do the side of angle A and divide it by side A. So that's the sine of 33 degrees divided by 13. This is going to equal the angle B and side B. So I'm going to use the sine of angle B and divide it by side B. So that's the sine of 50 degrees divided by side B. At this point, again, we're going to have a proportion that we could just cross multiply and solve for side B in this case. So B times the sine of 33 is going to equal 13 times the sine of 50. At this point, I still don't have my variable isolated, so I'm going to have to do one more step of dividing each side by the sine of 33. So if I divide by the sine of 33, it cancels on the left, leaving me with only side B. And on the right, I have this to put in my calculator. 13 times the sine of 50 degrees divided by the sine of 33 degrees. So let's go ahead and pull out our calculators. So first thing I need to do is, because I'm going to be taking the sine of 50 degrees, I want to check my mode and make sure that I'm in degree mode. Since I see that I am in degree, I can go ahead and get out of there, and then I want to start to enter the numerator. So I want to do 13 times the sine of 50. At this point, I would recommend we press enter, but don't round it, don't clear it out. We're going to take this entire value and divide by the sine of 33. So remember, the ANS means it's taking my previous value and putting the entire thing into the numerator, divided by sine 33. Once I press enter, that should be our side length for side B. If I round this, it looks like it's going to round to an 18.285. Again, please round your side lengths to 3 places, the nearest thousandth. Next, we are solving this triangle for, again, all the missing pieces. We know side B, but I still need to figure out side C and angle C. Well, just like when we are working with right triangles, the 3 angles of a triangle should still sum to 180 degrees. So if I want to find angle C, all I have to do is subtract the 2 angles we already know from 180. So if I go ahead in my calculator and subtract those, I find that angle C is going to be 97 degrees. Once you do that, again, we were given one angle and its opposite side. We can now use the new angle C value to solve for side C. I would again start with the ratio that I know. The sine of angle A divided by side A. So the sine of 33 divided by 13 is going to equal sine of angle C divided by side C. So the sine of the 97 degrees that we just found divided by side C. Again, to solve this, I'm going to do the same thing we did before. I want to cross multiply. And so I'm going to get that C times the sine of 33 degrees is equal to 13 times the sine of 97 degrees. Again, at this point, I need C by itself. So if I divide by what's being multiplied times C, the sine of 33, on each side, I'm going to get C to equal the 13 times the sine of 97 divided by the sine of 33. If we again put that in our calculator, I'm going to do 13 times the sine of 97, enter, divided by sine 33, enter. And it looks like side C is going to be about 23.691 units. Once we've done that, we've solved for our 3 missing parts. Let's go ahead and look at the one on the next page. So again, I want to start by writing everything I know. I know that side C is a length of 14. I know that angle B is 77 degrees. And I know that angle A is 32 degrees. In this case, if I look right now, I don't know any angle and its opposite side, so I don't have a ratio to start with. But since I know 2 of the 3 angles, I can easily subtract those 2 angles I know from 180 degrees to get angle C. That will allow me to have our ratio we need to start, where we know both an angle and an opposite side length. So the measure of angle C, again, is going to be 180 degrees minus our 32 degrees of angle A and the 77 degrees of angle B. If I go ahead and calculate that, angle C is going to be a length of 71 degrees. Again, I needed to know this so that I had one ratio to start with that I knew both its angle and opposite side length. Once you know that, we're going to have to solve for both side A and side B. It doesn't really matter which one you choose. So I'm going to go ahead and start with solving for side B. Again, the ratio I know is the sine of angle C divided by side C. So the sine of 71 divided by 14. And since I'm solving for side B, that's going to equal the sine of angle B over side B. So the sine of 77 degrees divided by side B. Why don't you take a minute and pause the video, cross multiply our proportion, and see what you get for side B. Please now take a minute and look at the proportion after I cross multiplied and notice what again I entered in my calculator. Side B should be about a length of 14.427. Once you agree with this, again pause the video and try to write the correct proportion to solve for side A. Please now check that you had the correct proportion to solve for side A. Then once I cross multiplied and divide out the sine of 71 and put everything in my calculator while it was in degree mode, I got that side A should be a length of about 7.846. Please now pause the video and try example 3 on your own. When you're done, correct it with the video. Please now check your answers for example 3. Notice in the beginning we were not given an angle and its opposite side length. So the first thing I had to do was solve for the missing angle B, which gave me 48 degrees. I was then able to use that as my beginning ratio when I made each proportion to solve for side C and side A. Notice I'm every time using the ones I was given because those are exact values. It's best to use the exact values given rather than a rounded answer you came up with. I also want to point out another way to check your answers when you're all done. One thing that you should remember from geometry is that the largest angle is always opposite the largest side. Here, angle C is the largest angle, and of the 3 side lengths we found, side C is the largest side. Also, the smallest angle should be opposite the smallest side, and angle A is opposite the smallest side. So that's a really quick way to check to see if your answers are reasonable. Again, pause the video, do example 4, and then check it when you're done. Notice in example 4, we were already given an angle and its opposite side length. So that is the ratio that I used each time that I knew both things for. Then, since I was given angle C, I solved for side C first and got a 27.524. In order to solve for side B, I had to first subtract the 2 angles I knew from 180. Then I was able to use the same ratio of my A's and set it equal to the sine of 80 over B. When I cross multiplied and divided out the sine of 36 multiplied times my variable, I got a 30.158. Please now take a look at your homework.